Okay, you guys, in this video, I would like to talk about set builder and interval notation. The notation that you see here written out between these braces or with these braces is called set builder notation. And the way that you read this, you say the set containing X, the braces, the set containing X, this line, such that, and then you have a description of what's happening with the X, okay? So -5 is less than or equal to X, and X is less than or equal to -3. So that's what you call set builder notation. So what this question wants you to do is to graph the description. So graph this, show what that is on a number line, and then write what we call interval notation. And your interval notation is your shortcut notation, okay? It's a little bit more concise. So if you'll notice that this inequality has bounds, okay, like a lesser bound and an upper bound, lower bound and an upper bound. The X is between those bounds. So X is falling between the -5 and the 3, the -5 and the -3. Now we also have to include the -5 and the 3 because of the equal to. Okay, so since that has the line, that means it's also equal to. So to denote an equal to, we would put a solid dot, and that denotes that X can be -5, it can be -3, but it also is between them. Okay, it is between them. So this is a picture of that compound inequality. So X has to be greater than or equal to -5. So see, it's over here. These are greater than -5. And X has to be less than or equal to -3. So these are going this way. That's less than or equal to -3. But it has to be those at the same time. So that's why it is between them. Okay, so interval notation. Well, what is interval notation? It's when you show us or show me numerically what the bounds are. So you take, well, okay, so the lower bound or the lower boundary was -5 and the upper boundary was -3. So the first number is always your lower boundary, the second number is always your upper boundary. And then you have to decide what kind of symbol to use around these. Well, if it was an equal to, like in this section right here in this problem, then you use a bracket to show it was an equal to. Okay? Now, let me change that up just a little bit. Suppose that my set notation was the set containing X such that -5 is less than X and X is less than or equal to -3. So I have not changed my bounds, okay? So my lower bound is -3 and my upper, or excuse me, -5 and my upper bound is -3. But what I have changed is what it would look like on the number line and what's included. So right here, this says I cannot include -5. So what do I use to demonstrate I cannot include -5? Well, I use a parentheses. And again, I have to include, that's the equal to, I have to include -3, so I use a bracket. So on the number line, this one would look like this. So here's -5, here's -3. We'd have that solid dot on -3 again because it was an equal to, but instead of a solid dot on -5, we would have an open circle because X can't be -5, it's not equal, but it can be -3. Okay, so what if I don't have an upper bound and a lower bound? You know, what if my lower bound, or what if this, you know, goes all the way and I shade the arrow? Well, not a big deal. You just won't see two numbers. So let's look at an example. So suppose that I have the set containing X such that X is greater than or equal to 2. So notice there's not two numbers, so there's only one bound, okay? And since I'm having X is greater than 2, so let's look at that on the number line. So here is 2, and I want all the numbers greater than or equal to 2. So since my number line looks like this, then if you notice 2 right here, is the smallest point, smallest number, and so that would be my lower bound. So my lower bound is 2, and I use a bracket because it had the equal to, but then this one doesn't stop, okay? So it's going out there forever and ever and ever and ever and ever. It's never ending, and so what do we use for that? We use an infinity. And so I'm going all the way to positive infinity, and I use a parentheses around an infinity because there's no bounds, okay?